Tēnā koutou katoa. Ko Tania Williams tōku inga. Welcome. My name is Tania Williams. I'm an engineer and a general manager of member services here at Engineering New Zealand Te Aorangaho. I have the privilege of hosting this climate conversation, and it is on slightly different to our previous ones, but on the Scott Base Redevelopment project. And I personally am extremely excited to hear about this. I'm sure you all know, but Scott Base is the strategic hub for scientists around Aotearoa and across the globe to carry out some of the most important research that's going on in the world. The redevelopment of this aging infrastructure will replace it with a safe, fit-for-purpose, sustainable research facility that will support New Zealand's presence in the Ross Sea region of Antarctica for around the next 50 years. This webinar today will talk through some of the challenges and about this exciting redevelopment, including the upgrade of the Ross Island wind energy system. So I'm thrilled to introduce you this afternoon now to our two presenters. On my right, hopefully that works, Karissa Hyde, am I right? Yep, can you wave? Yep, there you go. Scott Base Redevelopment Construction Manager at Antarctica New Zealand. So Carissa's role on the Scott Base Redevelopment project is to oversee the planning and construction of the new base. She's heavily involved in the appointment of the main contractor and has led the development of the construction, or will lead the development of the construction process, as well as the options and preferred approach to temporary base, because it's on the same site. Karissa has been working in engineering construction industry in Christchurch for over 15 years, previously held positions including project management, geotechnical and structural of a wide variety of projects, including the post-earthquake rebuild. Her roles working with local government and ministerial projects have given her a solid background in both the legal requirements and the best practice guidance associated with procurement, contracts, health and safety, environment, archaeology, and contaminated materials. She's also done a lot of work in sensitive environments. Now, Clare, on my left, is the project engineer for Antarctica New Zealand upgrade of the Ross Island wind farm energy care system. Clare oversees the technical development of the new 3 megawatt wind turbines, the large battery energy storage system, and the microgrid controls. Now, Clare is a chartered engineer, a specialist in development, procurement, and delivery of high penetration renewable wind energy grids, with particular focus on wind energy systems. She previously hails from Central Australia, where she has extensive experience working on large scale solar, hydro, and off-grid microgrid projects across Australia and the Pacific. So that is incredible to start off with, but welcome you both. Now, those of you who are on, we've heard that the presentation will be 35 to 45 minutes, and then there will be time for questions. So please, as Holly has said, please write your questions into the question and answer. But without further ado, I'll hand over to Karissa and Clare. Thank you very much.
Thank you so much, Tanya. Thank you, Holly, for facilitating this, and thank you everyone online for joining us. It's really great to be talking about this awesome project. And with that, I think we'll get straight in.
All right. Thanks, everybody. So today, this is just a quick overview of what we're going to be covering. So we'll touch on Antarctica and some of the contextual stuff for how Antarctica New Zealand works there. The reasons why we are redeveloping this space and the associated wind farm, the sustainable future of the base, and how we're going to go about constructing these new assets. There it goes. So Antarctica is the coldest, windiest, driest continent on the Earth. It is a desert, and it is an extreme and unforgiving environment. The area where New Zealand works is called the Ross Sea region, and that's located directly south of New Zealand, close by the American base at McMurdo. Antarctica itself is set aside under the Antarctic Treaty System as a place for peaceful scientific research. there is no, that's been, sorry, it's a bit muddled. This treaty covers all the parties around the world who've signed on to it. There isn't to be no war, no arms, no mining of any kind, all that sort of thing. It's just set aside for peaceful purposes and science. There are 5 gateway cities around the world that serve Antarctica. They're spread around, obviously, the bottom side of the globe, from Christchurch in New Zealand, Hobart in Australia, Argentina, Chile, and South Africa, and each tends to work on support a segment of Antarctica. Next slide. Sorry.
So Scott Base was originally developed in 1957 as part of the Trans-Antarctic Expedition, and the pictures you can see on the top of this slide give you an insight into how the base has kind of evolved from those original huts over the last sort of 50, 60 years. There hasn't really been any major upgrade at Scott Base for 30 odd years now. We're in a position where the infrastructure, it's pretty hard to get around, as Carissa will talk about later on. There's 11 different floors, which make it really hard to move equipment. You can see in the middle photo that there's pretty minimal space underfloor to access some of the life-supporting maintenance systems that we need at Scott Base. And it's getting increasingly inefficient to operate, and fundamentally is not fit for purpose as a base for New Zealand science for the next 50 years. That's part of the reason why we're upgrading Scott Base. We've also got the Ross Island wind energy system, which was commissioned by Meridian Energy in 2010 and was a pretty amazing system that really proved what we could do with renewable energy in Antarctica, and it's an amazing precedent for this project to be following on. That featured a power store flywheel, which was really a feature of its time that's now been pretty comprehensively replaced by batteries, and also a microgrid control system that for the first time linked up the New Zealand Scott Base and the nearby American McMurdo station. And in the last decade and a half, those systems worked really, really well, and enabled us to work collectively with our US neighbours. But at this point in time, by the time we get to the upgrade of Scott Base, the wind turbines will be nearing end of life. The power store is no longer fit for purpose. It's out of action and can't really be returned to service. And our control system is too inflexible for what we need it to be. So we're in a position where we're now taking on a holistic upgrade of both Scott Base and the critical energy systems that sustain it. So Scott Base Redevelopment was conceived as a way of moving forward for the next 50 years of science and presence in Antarctica. The Scott Base Redevelopment project has 5 really critical strategic objectives. The first is to maintain a continuous presence in the Ross dependency, which is something that's been maintained since 1957, even throughout COVID and all of the challenges that have happened. The second is to protect the Antarctic environment. The third is to provide an environment that keeps people safe and healthy. The fourth is to enable the logistics, the quite considerable logistics that can support high quality science at the bottom of the world. And fifth is to maintain New Zealand's credibility amongst the Antarctic treaty nations. We're not the only people that are doing major upgrades. There's quite a bit of work going down at Scott Base and broader Antarctica, but it's certainly one of the more innovative projects that's happening there.
So the project scope is split into 4 work streams. So the main base replacement, so that is replacing the existing sort of main buildings. That's with the 3 new interconnected buildings up on the left there. So that part of the project looks at the buildings as a whole. On the right, we've got the long-term science relocations. So off to the west of the existing base is an area of science installations and communications towers. Some of these science experiments have been in continuous operation since 1957. So as part of the project, we needed the ones that were going to be influenced by the redevelopment have been relocated and run in parallel for data overlap periods between 1 and 2 years to allow us to maintain that critical science data set. And that building you see on the top right is the long-term science building. It looks like it is 2 shipping containers. It's very high-tech on the inside, and it connects to a wide variety of science experiments. And it's got a great view over the ice. On the bottom left is the wind farm upgrade. So Claire will talk about that in a lot of detail. That supplies all the renewable energy to the grid. And on the bottom right is the existing base modifications. So this work stream is to allow us to have the capacity to do the redevelopment work. We need to increase, the existing base has 83 beds, and we need to increase that capacity up to about 159 to allow us to house contractors and scientists during the construction, so that we can maintain both our science work and continue and build this base. Yeah, all right, so this is a great aerial shot. So that's one from a drone or possibly a helicopter. That shows the existing base, or as it looked before we started the works. Because we've already started, I'll go into that on some later slides, but this photo is really good for showing sort of what the existing base looks like. So you can see the 12 separate buildings, all connected by walkways there, spread over 11 different levels, built over various years. Everything from the original yellow building at the bottom is a Trans-Antarctic Expedition hut from 1957. So that's one of Hillary's original flat pack huts that came down, and it has since been restored and turned into a museum of sorts that you can visit if you are lucky enough to be down at Scott Base. To the left are the long-term science installations that I talked about. So you can see there's a couple of small green buildings. Those are the geomagnetic huts. So they've been duplicated up at Arrival Heights, which is a site about 5 kilometres away. And then there's a lot of comms aerials and stuff also surrounding the base. We've got the foreshore down the front, so you can kind of see the line of, use my cursor, maybe it will show up. Here we go. This line around the front here is the foreshore. So we're on a bit of a little sort of a peninsula, a little knob that sticks out. So we're surrounded by sea ice for most of the year, but sometimes it breaks out, and then we've got open water out in front of the base. So that constrains our growth on that side. Up the back here, we've got, this is the main road to McMurdo up the hill. So that's the American base. And then it comes down here with a nice tight little hairpin and then goes out across the sea ice out to the airfields. So that is where everything from the airfields comes in on that road. So it can be quite a busy road on flight days. So as you can see, we've got quite a few different constraints around the place. And then we've got a lot of little outbuildings and storage and things all around the place. We've got everything to sustain a small city. So we've got wastewater treatment plant and outfall. We've got water intake and RO plant. We've got science labs. We've got a fuel tank system that connects into the base, and lots of storage for storing everything from our one seasonal supply ship that comes down in January each year. And this, we flick to the future. This is the new base. So the new base is located largely on the same site. It is further up the hill a little bit to allow us to keep the existing buildings to use for the accommodation of workers and scientists during construction, as we talked about before. Building A, which is the top building, is our accommodation and welfare building. So that has all the bedrooms. It has a lot of plant. It has the kitchen, the dining room, the bar, a lot of that sort of stuff. Bedrooms are a variety of single bedrooms, double bedrooms, and quad rooms, depending on how long you're there for. Depends how many roommates you get. If you're there all summer, you might get your own room, if you're lucky. Building B in the middle is a really key building for us. That's the science building. So that is a variety of science laboratories, offices, meeting spaces, science staging areas for prepping your gear before you go out in the field. biosecurity areas for making sure we don't affect both within Antarctica and coming back to New Zealand. And then building C at the bottom is workshops, engineering, a lot of storage facilities for the science gear. There's a big workshop in there that can take a bulldozer and the likes, because we have to be able to maintain all of our own gear. And there's a gym there as well with a nice view out over the ice shelf while you're working out. Those three buildings interlink with walkways, so you can go to any of those without going outside. Also, we have a hitching rail for vehicles to heat them, heli pads, because we do a lot of science via helicopters in the summer. And we also will have, again, a water intake and outfall and fuel storage system. Just a few numbers. The existing base is 4,800 square metres, and the new floor area of this new base is 8,600. And that allows us to bring a lot of the storage and things from the outside to inside, hopefully giving us a tidier and safer site for everyone who works there. Cool. And this is another view. So this is a nice elevation showing the three buildings with their staggered floor levels. So the bottom floor of each building above connects to the top floor of the one below, giving seamless access throughout the buildings. There are goods lifts in each building as well to transfer materials between floors, and all the linkways and hallways have been sized for pallet trolleys, so we can move gear around much more safely and easily than we can at the moment with all the stairs. There's a lot of manual handling at the moment.
So all of this is, of course, in aim of science. So some of the improvements that the new base brings, it has better science facilities. There'll be both wet and dry labs within the new building. The new long-term science building, which Karissa talked about before, has already been established in order to keep that continuity of data throughout the rebuild process. There's going to be quite a nice external testing area, a deck attached to one of the buildings that people will be able to go outside and just make sure their rig is fully tested before they're out into the field and dependent on it. And of course, the roof deck will be available for a lot of equipment that needs to be installed. One of the interesting aspects of this base is that it's been really set up to provide good biosecurity facilities. So we need to make sure that scientists coming in from one area aren't potentially contaminating scientists about to go out to another. So the flow of the buildings is really considered in order to optimise that. And the building as a whole has been designed aiming for 5 green stars, but that was a little more complex than anticipated because the green star process is based on a New Zealand building which has disabled car parks and stormwater and all of the things which aren't relevant in Antarctica. So we worked with the New Zealand Green Building Council in order to come up with a tool that is relevant for Antarctic programs, and given the number of other countries also updating their buildings, is hopefully going to be good precedent used moving forward. This then takes to the replacement of the Ross Island wind energy system. So this photo, you have to kind of squint to pick out the detail, but it shows how it all fits together. On the left, you can just make out some green buildings. It's Scott Base, located down at Pram Point. Then in the middle, you can see the 3 existing Enercon E33 wind turbines. And then over on the right, you've got the great expanse of McMurdo Station. And so there's about 3.5 kilometres that connects these 2 stations, which is quite unique for a lot of the Antarctic stations in Antarctica. There's often a lot more distance than that. And so prior to 2010, those stations were quite electrically isolated, each both operating on their own diesel-powered generators. And then the system in 2010 brought them together for the first time, and they've worked pretty well as a microgrid ever since. As part of our upgrades, we pretty much have to upgrade the entire grid. So starting at the top of this single line diagram, you can see 3 wind turbines. So that's the 3 existing Enercon E33 wind turbines that each rated to 330 kilowatts. So we are replacing those with 3 1 megawatt wind turbines that largely go in the same area, just because there's actually not too many places you can put wind turbines in Ross Island. They're slightly more spread out because they're a bit bigger. Then just off to the left, we see the battery that will replace the power store for grid stability and energy smoothing, and that will be connected electrically between the wind turbines on Crater Hill and then McMurdo Station. Then you've got McMurdo Station, and they've got their 5 existing generators. That's mainly for redundancy. You never need to have all 5 on, but they typically always operate with at least 1. And then over on the Scott Base side, because Scott Base operates at the New Zealand frequency of 50 hertz, the whole of Scott Base operates like that. So we have a frequency converter that's located within Scott Base just before the cable goes out and up the hill towards the wind farm. And that converts the frequency to 60 hertz, which is what the rest of the system operates at. So it's very, very similar concept to what the existing system has been. It's just all upgraded to represent a bigger wind capacity, and therefore the cabling and everything needs to be upgraded as well. There's a few really interesting parts associated with this project. So it was quite a challenge finding some wind turbines that would be fit for this purpose. Enercon have really moved away from the small wind turbine market, and those of you would know that a 1 megawatt turbine is tiny by current standards and therefore quite hard to obtain. But there's a company that we found in the Netherlands called Emerger Wind Technology that have really picked a niche of cold climate small wind turbines. So that was pretty perfect. The biggest they go is 1 megawatt. This will be the first for them in Antarctica, but they do have quite a few installations in Alaska. So they're pretty comfortable with the cold requirements and operating in those conditions. Importantly, this turbine is a direct drive technology, so it doesn't have a gearbox. And that was really important for us. It's the same as the existing Enercon turbines, but it's just something that we knew there was quite a high likelihood that there would be failure modes over the life of the turbine, and that becomes really difficult when you're in Antarctica, and it takes potentially another year for the ship to get a replacement gearbox down. So eliminating that entirely was quite a key driver for us. It's all rated to operate well in the cold. So Crater Hill can get down to about negative 50 degrees, which is a little warmer than what Karissa has to deal with down the bottom, but still provides some challenges. So these wind turbines will operate at full capacity down to negative 40. Once it reaches negative 40, they'll need to start shutting down just to protect themselves. But the turbine itself is rated for a survival temperature of negative 50. So all of the steel and everything has been cast to be fit for purpose. They're not actually that much bigger than what we have at the moment. So we have a 37 metre hub height with the existing Enercon turbines, and we're increasing that by 3 metres to 40 metres for the new system. And then going from 16 metre long blades to 26 metre long blades. Keeping the size compact was something that was really critical to us, because we have quite a lot of logistical challenges along the way, from the ship to the size crane that you can get down there, through getting the turbines offloaded off the ship, and you have to drive them through McMurdo Station. So the size turbines that you have in New Zealand these days just would never have worked from a logistical or load point of view. They have these remarkable foundations. I am an electrical engineer. I'm not a civil engineer, but the whole concept just blows my mind. So you can't pour concrete in Antarctica, which therefore eliminates what you would typically do for a wind turbine foundation. So this was a concept that Meridian Energy, with the consultants WSP/Opus, came up with the original system, and it works brilliantly. So we are following the same trajectory. You prefabricate these concrete blocks that you can see buried in the ground down here. They're about 2.2 metres by 2.2 metres in dimension. You prefabricate 8 of them in New Zealand, and then this steel spider that sits upon it. And then you place those 8 blocks in a circle, about 8 metres apart, bolt the steel spider foundation to it, and then that's it. They have anchors. Each concrete block has 2 anchors that go down about 10 to 12 metres and are iced into the ground, but they are purely there to resist uplift should something go really wrong with the turbine. We don't want them to really have to come into play. They're a backup mechanism. So it's a remarkably simple foundation design that has served the current turbines really, really well, and that's the path we're going down again for the bigger turbines. And then, of course, supporting the whole system will be the battery energy storage system. So we're looking in the order of 2 megawatts inverter size and 10 megawatts energy storage capacity. Many of you would understand the temperature challenges associated with batteries. They really don't like being cold. And so finding something that is both cost effective and not too untested, because you never really want to do untested in Antarctica, but also making it fit for those climatic conditions is something that we're currently working through. There's likely to be a tender that will be released in the coming months if anybody is interested in helping us out further with that one. One of the most interesting parts of this wind farm and the microgrid project is that it's a shared grid with the US. And that really makes this whole project work because it gives us a bit more load and it gives us a bit more diversity, and the US are a really important partner in terms of making sure the power system continues to operate securely. So Antarctica New Zealand is part of the Joint Logistics Pool, which alongside the US and the New Zealand Defence Force is a really important relationship that basically makes this whole operation work in Antarctica. You can see the bottom left photo is the US's C-17 plane landing on the ice, must have been 2008 or 9 odd, because that's the power store coming out the back of it in a 40-foot container. And so they flew that to site as part of shared relationships of making the whole system work really well. The photo on the right is the US's supply ship bringing down a whole bunch of containers and also the wind turbines, the original Enercon wind turbines. So it's a really important relationship, and one of New Zealand's key ways of contributing back to that is to gift McMurdo Station a whole bunch of the wind energy that is generated, which makes the whole system a lot more resilient, because otherwise you're reliant on special fuel ships coming down with specially modified Antarctic fuel. Our typical operation is that we have the wind turbines operating with the power store and soon to be the battery providing that smoothing capacity. And then we have always had to have at least one McMurdo diesel generator online. It's something that, of course, with the new wind turbines and the new bigger battery, we should be in a position to go diesel off in the future, but there are a lot of challenges associated with that are just going to take a little bit of time to work through. We've got to make sure our protection system can operate without the high fault current. We've got to make some changes to our earthing system that currently assumes that there's always a diesel generator online. And I guess one thing that surprised me coming from a hot place was that we've got to have a source of heat. Because at the moment the waste heat generation from those diesel generators is really, really important, and you can't just turn that off without having something else there to substitute it. So now we're just going to talk a little about construction. So the wind farm and Scott Base Redevelopment are all one project, but they're happening in slightly different timeframes. So just to talk about the wind farm construction for a moment, that's pretty much happening now. Our wind turbines have been purchased, and for those in Christchurch, you should be able to see them coming into Littleton by the end of the year. And then they're going to turn around and head straight south to Antarctica in January this coming year. We then will, this coming season, will then install the first wind turbine foundation. We found it was really important. This is something that the original system did, and we plan to as well, in that it's really important to put the first foundation in, ice in those anchors, and then just let everything go through a full freeze-thaw cycle before you come back and install quite a heavy turbine on it. It just allows things to settle and gives you an opportunity to re-level should you need to. So we'll come back a year later and actually install that first new wind turbine. We'll then, the same season, remove the existing wind turbines, because one new wind turbine will equal the output of the 3 current ones. And then once we've removed the existing turbines, we'll then have the space available to install the remaining foundations. Come back a year later, install the remaining turbines. The batteries plan to go in the 2025-2026 season, and come early 2026, the whole wind farm construction is pretty much done and dusted. We'll be powering McMurdo Station and old Scott Base and waiting patiently for new Scott Base to come along and connect in.
Thanks, Claire. Right, so the rest of the construction. Yeah, so we've also got quite a lot to do on the main base. So this slide is a lovely pictorial version of the construction methodology prepared by our architects. And this gives a nice high-level overview of sort of some of the key features. So the first step is obviously to establish our site for construction in New Zealand. So we'll be building the buildings entirely in Prime Port in Timaru. That by building there, it allows us to take advantage of local supply chains and build year round, and a few other things I'll touch on later. So we'll be building on temporary foundations using quite a traditional construction methodology. At the same time, we'll also be building at Clare Paynter in Antarctica. So we will be preparing the site, installing foundations and setting up our haul road and temporary wharf to allow the ship to dock. The ship, item 5 there, shows you sort of the ship docked in a Mediterranean style mooring there, which will allow the building modules to be rolled off when they arrive. So once the buildings are completed in New Zealand, they'll be tested and commissioned sort of as far as we can go in Timaru, running all the systems up, making any sort of repairs and checking on things before we then separate the modules for transport. So in order to allow us to transport them on the ship, we will be separating the larger buildings into 3 modules and the smaller building into 2, and then rolling them onto the ship in Timaru, sending them south across the Southern Ocean for generally 8 to 10 day voyage at sea, where they will be supported by an icebreaker to break into Pram Point, where we will then offload them up the haul road and onto the pre-prepared pile foundations. The buildings will then be joint back together and link bridges connected up, and then it's a sort of completion of the buildings following that. So a little bit more detail on some of the aspects. So this, we've already begun site preparation. So this drone footage is from February this year. So you can see the existing base at the bottom, and quite a big some earthwork started up the back. So in order to do the project, we had to relocate all the existing infrastructure that was in the way, basically. So we moved water tanks and power connections and communications masts, a whole lot of things. We've done all that this season. We've also done a round of earthworks testing. So that allows us to go and do a big bulk earthworks season next year. So we are taking the site and expanding the footprint sort of to the area you can see worked in this image here, to create a nice sort of approximately 10-degree slope across the site to form the building platform. And as part of that earthworks, we're also constructing a haul road. And if you can see my cursor, the buildings go about here, and then the haul road comes down the side here, around the buildings, across the front of the buildings, and then, oh, it's frozen. Of course it has. There, oh no, too far. There we go. That's where the temporary offload platform / wharf will go. It's not a wharf in the traditional sense. I tend to refer to it more as an off-road platform. So it has a couple of rows of piles for stabilisation, and then some large steel fenders that allow the ship to dock up against that are removable, because we get a lot of ice flows. Like if the sea ice does break out in front of the base, we get ice flows from the sort of right to left across the bottom of the page, which means we can't put any sort of permanent wharf structure there. Another part of the key works before the buildings arrive is this existing road I talked about before that comes down from McMurdo and does this hairpin in the middle of the base, tends to impinge a bit on our space and ability to function safely. So there's a lovely sort of natural line across the hillside here. So we're realigning the road up here, and that will be undertaken at the start of next season, which will allow us to deconflict this sort of large traffic route from the earthworks site and just give us a bit more space, because we're moving quite a bit of bulk fill around, so we'll need large areas for storage and the like. Also, we need to set up, before the buildings get there, we need to set up all the supporting infrastructure. So in addition to the wind farm, which is up the hill, there'll be a power cable coming down from the wind farm. There is also going to be a new bulk fuel storage facility up here that has the fuel supply for the base. And then out the front, we'll have a wastewater outfall, new water intake to supply us with the seawater. The actual wastewater treatment plant and RO plants are within the buildings proper, but the intakes and outfalls are obviously need to be ready before the buildings arrive. I think that's most of the things, and obviously a lot of services prep, so there's a lot of in-ground services and above-ground services to get ready for the buildings. There we go. At the same time in Timaru, so this is a great shot of the facility at Prime Port. So this was a logging wharf, so I think the logs have all been moved back to this area back here. So all this area in the foreground will be the Scott Base Redevelopment Construction site. We're beginning construction in the middle of this year, running for about 3.5 years. So we're aiming to have construction finished and testing and commissioning finished about 6 months before the ship arrives, to give us a nice buffer in there for any unforeseen circumstances. But by building in Timaru, this allows us to reduce the number of people in Antarctica, alleviate health and safety risks, and build year round. It also allows us an opportunity to test and commission the buildings in New Zealand, where it's much easier to get supplies and things if we have issues before we send them south, and it requires a much larger plane or ship to get the materials there. Also be training staff, and going to have a bit of a public open day too, so that will be something to look forward to in Timaru in 2026 sometime. So yeah, that's Timaru. And yeah, so here's a bit more detail on some of the key subcontractors. So our main contractor is Lee's Construction. They've been working with us as ECI contractor since 2020, but two of the key subcontractors that we have on board already are Big Lift. So Big Lift provide this MC class ship, which is they call it a modular carrier. It basically takes massive buildings and the like all around the world. It's ice strengthened, it works in conjunction with an icebreaker, and the deck is approximately the size of a rugby field. Slightly different dimensions, but that's about it. And it perfectly fits our base. We've maximised every inch of space on the back deck of that ship, to the point where we're moving handrails just to make sure we can get the ship safely on and off. But yeah, so Big Lift have been helping obviously with the design of the sea voyage and providing inputs into make sure that the buildings themselves can survive the voyage south. And the design team have been working really hard on designing and a testing program to prove that the buildings will survive, and also been working on what parts, if any, we don't put in the buildings until we get south. Things that are maybe more sensitive to damage are better just shipped south and installed as with the FF&E later. The image on the right are the self-propelled modular transporters. So these are, I think they've got about 18 axles on them or something. They're remote controlled, so you can see the small person behind them there with the cable. He's got a remote control there, and he is controlling. They link them all up, and you control these things, and you can set them all up in series and drive large-scale buildings, all sorts of things around to where you need it to go. So we're using these to separate the modules in New Zealand, to load them onto the ship, and then to offload them at the other end. And they have the ability to move up and down about 0.5 metre, so that allows them to drive under, lift it up, and then drive off again and place it and drop down again. and they travel south underneath the buildings on the back of the ship, so that they're there when we need them. Right, so once we get these modules to Antarctica, we have to, this image is, it's quite a cool one. It's where they've modelled how the trailers get the buildings onto the piles. So you can see we've got a field of piles there, 237 in total across the 3 buildings. They all have to be positioned within, I think, about 20 millimetres to allow, 20 millimetres to allow them to align correctly. So we'll be moving the modules one at a time. They're specifically ordered on the ship, so they come off in a very specific sequence to allow the buildings to be placed, because we have to do them in a very specific order to allow us to readjust the haul road between buildings, because it's quite a tight site in terms of grades and things. So the buildings, each module is driven into place on a sort of, there's a temporary haul road between the piles that lifts the SBMTs up to the height that they need. That will be removed on completion. So this is actually made out of a geofoam product that's produced here in New Zealand. We've tested it in Australia. We took it over to there, loaded up some SBMTs with some big heavy weights and checked deformations and all of those things, and it all came through well. So we're now planning to use that in Antarctica. They're basically, you get them to within about a couple of metres of each other. You take the temporary end caps off so it's all exposed, and then you roll them into place, and it's got locating pins both in the vertical and horizontal that allow them to pull together for the last little bit to make sure you get that perfect fit. And so once the buildings are next to each other, then you'll see a flurry of activities. You'll have a team of contractors there who will go around the outside, sealing the building on all 4 sides, roof, walls, underneath, to get them weather tight and ready. So the ship comes down in January. We need these things weather tight before winter, which is March. So there'll be a very busy period of offloading modules up the hill, getting them together on the piles, sealing around the outside, and then once we've done that, we move to the winter period. So we've got a much smaller crew. The ship departs, the SBMTs depart, and a smaller crew of contractors stay over the winter to test it, to complete internal works. So anything that was too sensitive to movements to come on the ship, anything that would be affected by the module joins, so finishing off all the joins internally, FF&E, and then joining up all the plant again, because as you can imagine, you can't have power cables running between 3 modules when you've cut them into 3 bits. So there's a lot of that work to do over winter, and then they'll test and commission it and run it in parallel with the existing base over that winter period to get us all our final data. And then come the start of the summer season, and so that'll be late 2027, we'll have consultants go down, inspect it, and then hopefully sign it off to hand over to Antarctica New Zealand to move into it. And then the final phase is everything that goes to Antarctica has to return to New Zealand. You can't leave anything in Antarctica. So we have to deconstruct the existing base and all the outbuildings that we're not using, and also the turbines as well. So as Claire said, the turbines have been designed in such a way that we're going to take them apart and send them back to New Zealand such that they can be on-sold for another use. We're doing similar things where possible with the existing base. So all materials will be returned to New Zealand for resale, reuse, recycling, and then if we have to, then we'll minimise as much as possible how much goes to landfill, because obviously sustainability is one of our key goals. This image on the left here is actually an old outbuilding. It was a hangar. This deconstruction photo is from February, so we've taken this down this year. So this is a good example of how we carefully deconstruct the buildings, containerise it all, and then it gets sent back to New Zealand for sorting and disposal, and hopefully mostly recycling.
So that's pretty much a wrap of the presentation. There's a couple of ways in which you can follow along if you'd like to find out more. So we have a newsletter that comes out about quarterly. It's a really good newsletter to sign up to. So that first website will take you to that point. There's also a number of jobs that are coming up with Antarctica New Zealand, and that's on our jobs website, but also with Leeds Construction. They'll have quite a number of opportunities opening up. And then finally, the government electronic tender service is where we publish any tender opportunities coming up. So we definitely have something coming up for the battery and quite possibly more as we go through. And all of these options are really great ways to get involved. It's going to take a lot of good people to bring this project to fruition. So yeah, we welcome any interest and encouragement as well. So thank you very much for listening to Karissa and I. We probably got some time for some questions.
Thank you both. Really, that was, wow, amazing project and such unique challenges and really impressive detail in the planning and problem solving that has to go into that. We do have a lot of questions, but I actually think that a lot of them you've answered as we've gone through, but just let me rattle through them. I'm just, for those online, I am going through them in the most upvoted ways. But there was questions early on about the challenges linking with the Americans and the different Hertz ratings and things. But I think I guess the last question, is there any other challenges in the linking with the American base that you haven't mentioned, Claire?
Oh, I think the hard work was done by our colleagues back in 2008. I think the first time you joined them up, there were a lot of challenges to work through, and it's operated pretty simply ever since. Probably one of the things that we are going to have to wrangle, and it's infinitely solvable, but power quality requirements and standards, because of course you have a lot of different options when you factor in the New Zealand requirements, the European requirements, where a lot of this specialist infrastructure comes from, and then of course the American requirements, and coming up with something that kind of is fit for purpose and meets everybody's objectives is a little bit challenging, but it's just something that we're currently working through.
Excellent, thank you. The next one, and sorry, they keep jumping if my eyes are funny, is that you talked about the working with other bases on the specifications and the designs. How much have the other bases impacted the specifications and designs of our one? Does that make sense?
Not 100% sure. I mean, I know what part of it we were talking about sharing information. I mean, there is one critical part of the project that's shared across all the treaty partners, and that's the comprehensive environmental evaluation. So there's no such thing as a resource consent in Antarctica, but instead we do this other process called a CEE. So we spent several years preparing this very meaty documentation that outlines exactly how we're going to do it all and how we're going to monitor and protect the environment through it and what we're going to do. And then that goes out for consultation for the large part of a year to all the treaty partners, and they provide feedback on that. Then we incorporate that, update it, and then final approval is given by MFAT, who are our monitoring agency that we report to. So that's one of the main ones. I mean, we do also participate in a few other, I'm not very good at the acronyms, but there's like CONMAP and some other ones where all the treaty partners get together, and we quite often will be doing presentations on different things that we're learning and so forth. So we'll do that.
Hugh Broughton Architects is the main architect on this, and he has a lot of Antarctic experience. He's been heavily involved in the British base, and he's working with the Australian Antarctic Division on their Davis master plan. So I think that brings in a lot of synergies as well.
Yeah. Oh, yeah. Just sharing information.
It makes complete sense. I'm just going to keep going. This one is, where does the discharge of the wastewater treatment plant go?
Yep. So the wastewater treatment is internal, and so the existing outfall and the new outfall are actually both in a very similar location. So if you recall, I said that small yellow building out the front, the Trans-Antarctic Expedition Hut, it's directly in front of that. So it's not far from base at all, but it is purely clean water at that point that it's going out. And then the ocean current goes from page right to left along the page. So obviously the intake is up current from the outfall, being a key driver there.
Understood. All right, next one. Why not retain more of the existing base given the difficulties in constructing in Antarctica?
So when this project has been going on for probably nearly 10 years now, and back in the early stages they looked at several different concepts, including just upgrading some of the existing base, keeping like sort of one of the newer buildings, and then building 2 supplementary buildings, and then building a whole new system. And as part of that process, the interlinking of the systems and the ability for, like, we're not finishing this project till 2027, 28. So a lot of these buildings are so far past their end of life, they're not viable anymore. And then the kind of one that is maybe could be utilised it just didn't quite fit right with the system and what we needed. We did look into it on several occasions, but it just wasn't deemed to be feasible.
Now, the people interested in staff welfare, why was the decision made of the location of A and C? Why did the better views not go to the people's residence? Paraphrase.
Well, all of the areas have beautiful views, so they're staggered down the hill. So even if you're in the top building, you can still see the view to Erebus, which is a key mountain for us, is actually from the top building, and you can see there's little lounges spread throughout the different buildings where people can sit and be reflective and have some time, and these all have stunning views. There's honestly stunning views in all 4 directions. It's an amazing place.
The next bit is you refer to 5 green stars. They're wondering if that is, what is that? Is that our, the green stars the same as here in New Zealand? And is that something that the treaty partners must apply?
No, so no one in Antarctica has done it before. It was just a preference of Antarctica New Zealand to aim for the highest standard and sustainability that we could. It's equivalent to a 5 green star rating in New Zealand, but with the caveat that we've had to work with the New Zealand Green Building Council, as Claire said, to rewrite the tool to be more Antarctic specific. So writing things, changing it up slightly so that it was more useful to the environment. And then as part of that, we're also presented that tool that we've developed to other national Antarctic programs, and some of them may look into using it in the future. So there may be more green star buildings in Antarctica to come.
Excellent. Sorry about the rapid fire, but there are 31 more questions, so I'm not going to get through them all. I'm just warning everybody, but we will see if we can get answers to a lot of them. The next one is about the earthworks, and where does the waste material for the bulk earthworks go, or is there a really strict cut to fill methodology? How because you're talking about all the waste going off, but on the earthworks part, is there any waste there?
Yep, no, I can answer that. So soil in Antarctica is very precious. It's definitely not deemed waste. To bring any soil back to New Zealand, you have to actually get a permit, because I think it's only, I'm not 100%, I think it's around the 5% of Antarctica is actually covered in soil, and the rest is ice and water. So we are working on a largely a cut to fill balance. We have a bit more cut than fill at the moment. We need it to allow us to manage get the grades that we need for some of the items. So we've got to do our own. We've got to excavate, process, and place all of our own material. There's no quarry to go to or anything, so it's all on site. But if there is any extra capacity, we'll just use it around the site to landscape as thoughtfully and as possible to maintain the look and feel of the base and the environment.
Another question is, are we able to have access to the slides as well as the recording?
Yeah, sure.
Sorry, it keeps jumping. What is the depth, sea depth of the proposed offloading ring?
At the shore, or
yeah.
So the ship, the ship needs about 12 metres at the front. So at the moment we're doing some bathymetric survey to work out the exact position of that offload at the front. At the far end, the reason we're doing a Mediterranean mooring is because the seabed there is, it's a volcano, so it's very steep down, and out the front it's over 200 metres at the front of the ship. So that's why they can't moor in a more traditional sense.
No, understood. Somebody's interested, the concrete pouring, is this you physically can't pour concrete at the base, or is it a rule that you can't?
Oh, it's just very difficult because of the temperatures. It would be really difficult for it to cure properly, and it's easy enough for us to prefabricate them in New Zealand. Saying that, the Australian division did pour concrete for their wind turbine foundations, but they had to do warming mats and a whole host of other things that we're quite keen to avoid. It's not a rule, it's just you want to keep things boring if you can in Antarctica.
Yeah, we do small grout batches when we need, so we tend to do high strength grout, but we tend to mix those inside the buildings and then take them outside and place them. And then obviously special high strength grout from Canada that's made to deal with those kind of temperatures. And it's also a water thing as well. So every bit of water that we make at the base is RO from seawater. So there's a high energy demand to do that. So you don't want to be making a lot of water to turn into concrete. That makes sense.
Yeah, absolutely. Another question, what is the cost of all these upgrades?
$344 million that was awarded in funding to this project.
And that includes all the energy?
Yeah, yeah, the wind farm's included in that. All four of the items that Karissa talked about.
Okay, this one's about the turbines. Mentioned that one new turbine will be installed and then 3 existing turbines will be decommissioned before the next 2 new turbines are installed. What is the plan if the one new turbine fails?
Well, I guess we've got lots of stopgaps along the way to stop something from failing. The rationale is we want to maintain wind supply throughout, because if you take, even though the turbines at the moment are smaller, even if you take that out, it actually has a really substantial impact on fuel consumption and generator maintenance. So there's a desire to keep that going the whole way along. Look, I guess there would be numerous opportunities to assess the viability of the first wind turbine before we took down the others, but it's certainly not something we are expecting to happen.
Okay, I'm going to have time for one more. Where am I supposed to be? Oh, are you upgrading the water treatment and wastewater treatment and disposal facilities at the same time?
Yes, so the existing ones are housed within the existing buildings. The new ones will come inside the new base buildings. So they'll be new and sized for the new base population. We're using a vacuum system within the new base, which will help reduce our water demand and lead for an efficient wastewater treatment system.
Very last question, because there's plenty more questions, but I'm going to go with, what is the design life of the base, and was the sea level rise and other impacts of climate change considered during the design?
Yes, so the design life of the base is 50 years, in line with the New Zealand Building Code, and yes, there were studies done on volcanoes, earthquakes, tsunamis, sea level rise, all of the above. And that's why the majority of the base is uphill, so that is well above any tsunami level. Obviously the foreshore type infrastructure, being the intakes and outfalls and things, that is within the tsunami range, but you can't avoid that. But But yeah, so generally we try and keep all the infrastructure above that. And we did studies on all of them.
Carissa and Claire, thank you so much. We are also getting lots of confirmation of such an awesome, wonderful, really impressive presentation from you both. All the very best in the next couple of years. This is an awesome project and we look forward to hearing the updates, but thank you so much for sharing it with us. Our audience was glued to their screens and have a huge amount of questions and admiration for what you both are doing. So thank you so much. Really appreciate that. Thank you all that are still on for joining us today. Just a reminder that you can register for any of the next climate conversations on our website. Also, you can listen to for free to any that you've missed, including this one when we get it up. So please join us on those. But otherwise, have a great afternoon and a great weekend, and thank you all for joining us.
Thanks very much.